Hi everyone, welcome to the video over exponential functions. So first off, an exponential function is in the form of a times b to the x power. We know it's an exponential function because the exponent is x. A is going to represent our initial value, which is our starting amount, and b is going to represent our common factor, which is what we multiply by. It's also known as our growth or decay value. So I have here some exponential rules or properties of exponents or law of exponents that you have learned in previous math courses. This will be used more when we start solving. So you can go ahead and read over those yourself, but I will discuss these more in depth in a later video. Now we have to talk about growth and decay. So when we are talking about growth and decay, we have to make sure that we read our graph from left to right. So let's go ahead and write that out. Okay, so if we're looking at growth, our growth, that means our graph is increasing from left to right. So from left to right, it is going up, which is also known as increasing. To tell from an equation, our b value has to be greater than 1. So an example equation that represents growth would be something like f of x equals 2 times something to the x power. Okay, that something in parentheses has to be bigger than 1. It can be any number at all, so let's just say 4. That right there would represent exponential growth because the number raised to the exponent is greater than 1. If we look at our second one, this is decay. Decay means our graph is decreasing from left to right, which means it's going down from left to right. Okay, decay is decreasing. In an equation, okay, our b value has to be between 0 and 1. So if we have an example equation, whatever is being raised to the exponent of x needs to be between 0 and 1. So something could be 1/4, could be 0.25, 0.1, 0.3, 4/5, anything that would be between 0 and 1. Now, I do want to take a second and talk a little more about the graphs and some of their key features. So I'm going to zoom in on this first one. So this first one, what I want y'all to remember is that exponential functions have a horizontal asymptote. Okay, it's where it starts to go flat. So this is our horizontal asymptote. Its equation is y equals 0. Okay, so when we're talking about domain and range, the horizontal asymptote is going to affect our range. Something you need to know is the domain of all exponential functions is all real numbers. And our range goes based off our horizontal asymptote. So all of our values are greater than our horizontal asymptote. So we would say y is greater than 0, which is the horizontal asymptote. Okay, I hope you can identify your y-intercept. It's crossing at 2. Your x-intercept, it does not have one because of the asymptote. Okay. Now, looking at this next one, this also has a horizontal asymptote at 0. So its domain and range would be the exact same of the one right above it. Okay, but I do want us to sketch one that looks a little different. Okay, so if we have this graph right here, and we have the function that looks like this, okay, this still has a horizontal asymptote at 0. Y equals 0, but its range has changed. So the range of this picture that I just drew is y is less than our horizontal asymptote. Okay, so you have to be cautious of, is it above the asymptote or below the asymptote? Now, shifting gears into transformations. Okay, just making sure that you understand that transformations are the same for every single function. So if A is negative, it causes it to reflect, which looks like this picture over here that I just drew. If the absolute value of A is greater than 1, it's a vertical stretch. If the absolute value falls between 0 and 1, it's a vertical compression. Then we have C. If it looks like plus C, it moves to the left. If it looks like minus C, it moves to the right. Remember, it likes to act the opposite. And then D causes it to move up if it's positive and down if it's negative. Now, one thing I do want to add is that if X is negative, so if I just have a negative X as an exponent, that causes my graph to flip or reflect over the y-axis. Okay, reflects over the y-axis. And then I do want to add the parent function. So the parent function, remember, is our most basic function. If we take away all transformations, it would be what's left over. Well, if I took away all transformations, that means I'm taking away A, C, and D, and that would just leave me with B to the x power. So whatever your base is, raised to your exponent, is always going to be your parent function. Okay, so we have two quick examples that we're going to go over. So given the exponential function f of x, identify the following information. So we have a equation right here. We have the graph of the equation right there. We need to identify if it's growth or decay. Well, looking at our picture, it is increasing from left to right, which means it's showing growth. If you look at the equation, 5/2 is equal to 2.5, and that would be our B value, which means it's greater than 1, which means that it's growth if we look back up top right here. Okay, so it's growth. You can tell two different ways by looking at the graph or the equation. The x-intercept, well, we see that it has a horizontal asymptote at y equals 0, which means it's not going to have an x-intercept. There is not one. It will not cross the x-axis. The y-intercept is crossing right here at 3. The horizontal asymptote is that red dotted line. It's kind of hard to see, but it's there. And we said earlier that it was at y equals 0. The horizontal asymptote will shift if we move our function up or down. So if we have that transformation that moves it vertically, it's going to move our asymptote. Our domain is all real numbers. It is going to keep extending to the left, and it's going to keep extending to the right forever and ever and ever. So that's why it's all real numbers. Okay, our range is bottom to top. It's starting at 0 and it's always getting greater than 0. So our y values are y is greater than 0. 0 comes from that asymptote. And that's it for those key features. Looking at number 2, identify the parent function of f of x and describe the transformations that take place with g of x. So first thing we want to do is we want to identify our parent function. Our parent function is the most basic function without any transformations. So that means I'm going to take away the 1/2. I'm going to take away the plus 5, and I'm also going to take away the minus 9. All three of those numbers are transformations. So if I take all of those away, what am I left with? The base 3 raised to the exponent x, and that's it for the parent function. It will always be the base raised to the x power. So now we can talk about the transformations. The 1/2 is in the spot of A. So there's no negative in front of it, which means it's not reflecting. So that means I'm left with a vertical, and because it's between 0 and 1, compression. Okay, the 5 looks like a plus sign, but we know that it goes in the opposite direction. So instead of moving in the positive direction, it moves to the left 5 units. And that 9 being on the outside means that it goes down 9 units. So if you have any questions over these exponential functions and any of its key features and transformations, please let me know so I can help you out. And I will see you in the next video.